The Stratospheric Observatory for Infrared Astronomy took its final flight this past fall before retiring to the Pima Air and Space Museum here in Tucson, Arizona. It bridged the gap between space-based and ground-based telescopes, using its unique advantage of seeing in the infrared while still near Earth, getting to any place on the globe, and being able to be fixed or updated after every flight to collect valuable scientific data. It could be the last of its kind, at least for a while, but it definitely wasn't the first. Airborne astronomy didn't start with jumbo jets or big converted passenger planes. It didn't even start with planes at all. The first non-ground-based astronomy was all about balloons. Astronomers would rig up telescopes to big stratospheric weather balloons and essentially cross their fingers. They had some control over where the balloons went, but that didn't mean it wasn't a difficult process. These balloons soared higher than any plane could, going up to 50 kilometers above the surface. For an idea of how high that is, SOFIA's upper limit was around 15 kilometers. A whole video could be made on the history of using weather balloons for astronomy, and the contemporary of it too, because we're still using them for specialized projects today. But we'll save that for another time. We're here to talk about planes after all. Before NASA even existed, there were people using aircraft to get a better look into space. Mostly, people were trying to fly into eclipses. See, solar eclipses are an amazing phenomenon to look at, but they can also tell us a lot about the sun. And in the days when we were pretty limited as far as our infrared astronomy, eclipses were vital to figuring out what exactly was going on with our star. The eclipse adventures began with an organized Navy flight for the September 1923 solar eclipse. They wanted to determine the center line of the eclipse to see if their models were correct. And while the observations in the moment were useful, all the photos they attempted to take weren't. But it was a solid first flight, and it paved the way for many more. In subsequent years, the Honey Lake Expedition of 1930 and the National Geographic Society and Army Air Corps flight of 1932 did similar observations with much more success. There was a limit to how much more could be done after these missions, however, since these were still open airplanes. The Nat Geo mission was able to fly up to 27,000 feet, which was an altitude where the pilot and the astronomer on board both had to wrap themselves up in several layers of clothing and use oxygen, and the pilot noticed he was getting disoriented easily at such a high altitude. Airborne astronomy was pushing the limits of aircraft technology, and it was getting a little dangerous. Luckily, airlines started to realize that people might want to use airplanes to travel in, and astronomy got to benefit from that too. The next big expeditions to fly eclipses were done by the Royal Canadian Air Force in July of 1945, and then by a program called the Aerial Photography of the Eclipse of the Quiet Sun. It's very fancy. For these, they were finally flying in enclosed planes, and the Quiet Sun program was able to have 55 scientists aboard the modified Delta Airlines plane. By flying along the path of the eclipse shadow, they were able to stretch totality from 100 to 142 seconds. Within a couple of days of the eclipse, that plane was back to flying passengers across the country. See, there was no dedicated airborne observatory up until this point, all the planes simply being borrowed and fitted with telescopes and cameras for each instance that they were needed. But with advances in air technology and so much potential, it wasn't long until NASA decided they wanted something permanent. Enter the Galileo Airborne Observatory, an aircraft made to permanently house astronomy equipment. The plane itself was a Convair 990, modified to fit 13 apertures capable of holding optical quality glass along the left side of the plane. Its first mission was, say it with me, an eclipse, specifically the one in May of 1965. But the Galileo observed much more than its predecessors. It observed comet Ikea-Secchi, a Mars opposition, and the sun and planets in the infrared wavelengths. Gerard Kuiper even hopped aboard to use the infrared capabilities, getting important data on Venus that showed the planet's clouds weren't actually made of water. Sadly, the Galileo Observatory was tragically short-lived. The aircraft collided with another plane while trying to land in 1973. While a terrible end to this observatory, the field of airborne astronomy didn't end with it, as there was another telescope already flying, this one aboard a NASA Ames Learjet. In the Galileo Observatory, observations were done by looking through the windows, but astronomers wanted a clearer view, so the Learjet became the first open-port observatory design. The telescope was a 12-inch infrared reflector that sat in the passenger window area. The concept was a success, and the plane was able to fly at an altitude of between 45 and 50,000 feet for up to 2.5 hours at a time, allowing for such amazing discoveries as the first measurements of the internal energies of Jupiter and Saturn, far infrared looks at the Orion Nebula, and studies of the star-forming regions at the center of the Milky Way. The Learjet flew throughout the 70s and well past when the next Airborne Observatory was created. First weather balloons, then open airplanes, then jets, and finally, a starlifter. The Kuiper Airborne Observatory was unlike anything that came before it. Built into a modified Lockheed C-141A starlifter, the observatory was centered around a 36-inch open-port Cassegrain telescope that could see in the infrared range from 1 to 100 micrometers. It could also fly at up to 48,000 feet for up to 7.5 hours. That massive jump in flight time from the Learjet and Galileo allowed for so much more science to be done at a level above almost all of the atmosphere's infrared blocking water vapor. And the size of the plane itself allowed for up to 20 scientists on board at a time. Kuiper averaged about 70 flights per year during the nearly 2 decades it was active, from 1974 to 1995. And as far as what it discovered, the list goes on and on. Confirmation of Pluto's atmosphere, the rings of Uranus, a star-forming ring around the center of our galaxy, water in comets and in Jupiter's atmosphere, the formation of heavy elements in a supernova, data on complex organic molecules and water distribution throughout star-forming regions. And keep in mind, this was all at a time when the only infrared space telescope we had was the Infrared Astronomical satellite, and that had a short and specific mission of mapping the entire sky in IR. Kuiper was the only tool that had both the versatility and physical range that could see in infrared wavelengths. At least, until SOFIA came along, but that's a whole other video. Kuiper has since been retired and rests at Moffett Field. Not airworthy, but still an incredible piece of history, along with all the other ways we put telescopes into the sky. But seriously, SOFIA is a whole other video, and we made it, and you can watch it right here.